Good afternoon. It's a lovely sunny day here in Yorkshire, UK. I've had this Volkswagen e-up for 6 months. My first EV, I love this car. I'm not pushing EVs, don't turn off. What I'm really here to talk about is this wall charging point, which I've had for 5 months. I'm experiencing some problems which any wall charger might experience, plus I've had some problems specific to this Give Energy wall charger, which are fixed now. Now you probably know, if you follow the channel, I've got solar and a home battery. Why do I mention that? Well, because I'm having a problem with over voltage. This thing is complaining that my voltage is too high. To some extent, that's being pushed up by the solar panels, because when the solar panels and the inverter are trying to export to the grid, the voltage in the home has to be a little bit higher to get the current to flow out to the door, out of the cable anyway, maybe a volt, something like that. And if your grid voltage from the street is generally high and you add another volt to it, this thing can trip is the right word, alarm and isolate the car, and it goes into a kind of mode, which I'll show you, which says, I think there's a fault. I've isolated the car. I'm going to wait a while before I reconnect. This is what I see. 6 green flashes and 2 red flashes, and it just cycles round those. And then it waits for so long, not sure, 15, 20 minutes maybe, then it resets itself and then it's fine until it detects another over voltage, and then it goes back into this mode. And when it's in this mode, it disconnects the car. Now, to stress again, that is not specific to this brand of charger. It's a general problem if your supply voltage is too high. So a bit of history. Some years ago, a few decades ago, the standard voltage in the UK was 240 volts single phase for your home. And on the continent, it was 220 volts. Now, around 1995, they decided to harmonise the voltage between the UK and the continent, so Europe I mean. And they said, well, we'll make it 230 volts. Everybody will be on 230 volts, except they won't be. But they'll at least be within the tolerance. And the tolerance is, for here, plus 10%, minus 6%. So the voltage here can range, so it's nominal 230, but can range from 207 up to 253. So as long as it's within that range, the distribution company is doing its job and everything's fine. But if the voltage at your home goes over 253 volts or below 207, for the general sort of charger, for EV charger I mean, it's going to say, over or under voltage, that's possibly a fault. We'll go into this reset cycle and we'll disconnect the car. Now, why does it do that? Bit of technical here, but it isn't too deep. So for most homes in the UK, the cable that comes in from the street only has 2 wires. When it gets into your home, they split one of those wires, the neutral, to make it neutral and earth. So most of the time, not always, but a lot of the time, when you see a plug and it's got live, neutral and earth on it, the live is live, the neutral is earth as well, although it's split as it comes into your home. Won't go into too much detail, that's fine. But the problem is that you can get a particular type of fault if somebody in the street digs through your supply cable and they cut the neutral line. So remember, there's only 2 wires come to your house. They cut the neutral line, then things in your house can float up to the line voltage. So you could have a situation where that neutral's cut and your outside tap becomes live, for example. Now, there is protection that will protect you from that, but if that protection fails, you could get a nasty shock or worse. Now, a tap is likely to be earthed, well, protected in a way because it's cemented into the wall, and it'll lose some of that risk by being connected to the fabric of the house. But a car is on 4 rubber donuts and therefore is completely isolated. And if you got that particular type of fault, which is called a PEN fault, protective earth neutral fault, the neutral in the house could float up to live. Yes, that's right. You come along, touch the car. If the protection in your home doesn't work, you could get a very nasty shock and it could be dangerous. So these detect that, sometimes in sophisticated ways, which are reliable, but sometimes in less sophisticated ways, which are not so reliable. And this particular model and many others from other companies do this. They say, well, if the voltage is over 253 or below 207, there's potentially this very dangerous PEN fault, and we'll go into reset mode and we'll isolate the car. Why am I talking about this, if you're still here? Well, because I don't think we were ever reset to 230 volts. I think, like I said, they just relied on the tolerance of the grid network. So your starting voltage is probably still nominal 240 volts. But actually, in practice, it's often a lot higher. And if you ever look at the charts, my inverter gives me a chart of grid voltage, and it could be start the day at 245, and then during the course of the day, particularly if the sun's up and we're getting that extra volt applied by the inverter to export the power, you can be over 253 volts. So on bright sunny days, this thing is tripping and it's going, oh, well, there could be a PEN fault. It's over 253 volts. Let's isolate the car. Now, if I really wanted to charge there and then, what I can do is reset this. I can reset it from the app, or I can just go and turn the switch and isolate it and turn it on again. And if I'm quick, plug in. And once it's under load, the load of charging the car is enough to bring down that voltage a little bit. So if I'm quick, I'd be able to get it to charge in the day on a very sunny day. But this thing's tripping 6 or 8 times a day at the moment. And sometimes even in the late evening, as I check the grid voltage on a meter which is by the incoming supply. So there's no sun. I'm still getting 248, 250 volts. Sometimes more. So it's a general problem in the UK. This is my incoming supply here, and there's the CT clamp. This one CT clamp serves both the inverter and the EV charger because all the equipment is from Give Energy. Oh, these books, by the way, they're only to make us look intelligent. We never actually look at any of these. So EV chargers don't tend to report the voltage. So it can be difficult to know if you've got a problem. But if you've got an inverter, you would get a data report from the inverter anyway, but you also might have one of these, which is called a 115 meter. Now, these things display lots of information. If you press this button sequentially, you get various different bits of data, import, export, all sorts of stuff actually. But pressing this should tell me what the current voltage is, and it's 252.4 I can read. So that's quite useful, but it's difficult to measure voltage very accurately. So if you go to Amazon or something and buy a voltmeter, it might be accurate 1% plus 3 digits or minus. This is better. It's accurate to within 0.5%. But even 0.5% is plus or minus 1.25 volts. So if you're trying to track down a fault and you're using this, which is pretty good, you could still, be a bit off. And also there's a voltage drop between this in the house and my inverter, which is down the yard. Now it's quite a long cable, although it is a big fat cable. It probably would only drop 0.5 volt between. But you can see how, with all this tied to the grid voltage, if the grid voltage is a bit high, you can add on something like 0.5 volt going down there to the inverter. You can then add on a volt for the inverter to push the power and export it, push it out of the door, down this cable, actually. to the meter and outdoors. So it all kind of adds up. Anyway, let's have a look at the data that we see from the inverter. That's another view of all of this. This is my inverter data for this morning. So over here you can see the grid voltage, and this red trace is tracking the grid voltage. So at midnight the grid voltage was 252.3 volts. Now we don't get sunshine at midnight here. And look at these variations as you track along. I'll just take that away. So you see the variations as we track along. But interestingly, we had a peak there of 253.3. If that lasted for more than 5 seconds, it would trip that EV charger. But then as the sun comes up, the sun is the yellow, solar generation, the voltage is falling, look. And then we get this sudden peak over here. So that is 252.8, just a sudden peak. And then it's generally falling. Now it has got a little bit duller as we've moved up to lunchtime. So this is just 12 at night to 12 lunchtime today. It has got a bit duller, but look at these variations here. So for a long time in my life, I never even thought about grid voltage. You turn the TV on and it works. What is there to know? It's 240 volts, isn't it? Everybody knows that. But in reality, it's nothing like that. I'm really surprised how much variation you get almost minute to minute with this. Now, the way that the grid company can control this, can fix this, if you like, is they can change the tappings on the supply transformer. Around here, we don't have transformers on poles like they do in some countries. You get a transformer local to your group of houses. It's normally an 11,000 volt feed into that. And the assumption in the design was always that the voltage falls towards the houses. So they're more concerned about jacking up the voltage. People come along with really heavy loads, the voltage is falling, so they tap the transformer. And I don't even know if they tap it in your local transformer. They may tap it in the next transformer up, which I think would be 132,000 volts. I'm not an expert. I'm guessing that's the next level. So it might be in your district, but not very local to you. And they're not really designed so much, somebody might correct me, for tapping down. They're more designed for tapping up on this assumption that the voltage falls towards your home. So more and more, as people get solar panels, which are just lifting the voltage, it's reducing demand. These things are not, what's the right word, electronic. The regulation isn't electronic as far as I know. It just relies on old-fashioned electrics, where you put more load on, the voltage starts to fall, and then they just tap it up to rise it, and then it fluctuates during the day as people are changing their usage, turning on their kettles, cookers, all of that stuff. So I don't know what's going to happen about that. You can complain to your district distribution network operator, but they're a bit reluctant to do anything. They would come along, they'd put a meter on, you'd be asked to disconnect your solar panels for a week maybe, and if it comes out of the voltage supply, comes out of this range 253 volts, then they might change the tapping on the transformer locally-ish. But if some people are on the end of a long overhead line somewhere, because we're all ground fed here, they might be low on voltage, so if you drop yours down, it could drop somebody else's too low. So it's quite difficult. I got the feeling it's not really designed for any of this. And I think I've just read that all new houses are going to have solar panels. So this is, maybe they'd have a new transformer locally, and that would be more centered on 230 volts, so they'd have more headroom. I'm talking a lot, but it's quite a big topic. So maybe these should have more sophisticated pen fault detectors in them. Some of them do, I know, and some of them have been moved up to detecting a fault at 255 volts, not 253. And I suppose they could do it with a firmware change, I'm not sure. But it is becoming a bit of a pain in the behind, really. So that's one practical experience that one might not have thought of if you haven't got one of these. Now the second point is to do with this specific model from Give Energy, a problem I never expected to have. Now this thing, because it draws 7.5 kilowatts, it could be drawing too much current for your home if you've got all sorts of other appliances on. So it has a way of detecting, it's called a CT clamp, but it detects how much current's been drawn in your main supply. And if this starts to charge and it's overdrawing the current on your main supply, we're fused at 80 amps here, then it'll throttle back. Now it's a long way from here to the front of my house where the supply comes in, and I don't want to be running a separate cable all that way. And so this, because it's give energy and the other components are give energy, I can use the CT clamp that's already been put in for the inverter. And so it sort of piggies one off the other. Now, to connect this to the inverter, you can do it in one of two ways. You can either have a physical Ethernet cable, or you can have Wi-Fi. And there was a fault, a genuine fault on this. Believe it or not, although this has been out for more than a year as a product, it had a fault. If you were using that mode where you were relying on the inverter to control this, so you didn't need a second CT clamp separate for this, it would only work if you were on Wi-Fi. There was a problem, too much detail, there was a problem if it was on Ethernet, which should be the most secure. And when I say secure, I mean most reliable, because we know Wi-Fi can be flaky at a range. So the result was, I'm on an intelligent tariff, Intelligent Octopus Go. The way that works is you plug in the charger, the car detects it's being charged, it tells Volkswagen, Volkswagen tell Octopus, Octopus send a signal to Volkswagen to say to the car, stop charging, and then we'll start charging when it's cheap rate. But when the car stopped charging, this, because of the fault I've just described, was going, no, I don't want to stop charging, I want to keep charging. So this thing kept resetting and nagging all the time, nagging the car to charge. Now the comedy was, if I used the little granny charger, excuse me, I'll just show you what I mean. I should have had this ready. If I use this thing, which charges at 2.3 kilowatts, this is 7.5, this behaved itself. This only plugs in from our supply, 3-pin plugs like we have there. So this would behave itself, and I could use, once I'd registered for Intelligent Octopus Go, I could actually use this charger. Whether you're supposed to, I don't know. And it meant that Octopus was trying to charge, and it was having to give me extra slots during the course of the night to get it charged by the time I said, which I think is 8 o'clock in the morning. But still, it was fine. Nobody seemed to mind, except it wasn't charging that quickly. But this thing I couldn't use until I got a firmware update, actually for the inverter, not for this, for the inverter itself, so that the inverter communicated properly with this and controlled this properly on a wired Ethernet cable. So that's all done now, and I'm happy with that. So the only problem that I have is this pen fault detection, spurious alarm, etc. And it doesn't help that this thing says earth leakage, earth leakage. That's what it tells me on the app, but it's not earth leakage, it is overvoltage, because it just has the one report for both things that it's trying to detect. Now, talking about the car, well, this car, in this warm weather, it's over 20 degrees centigrade here, it's probably 23 or 24 in the sun. Can't do that in Fahrenheit right now. It'll get 5.5 miles per kilowatt easily. So if you don't know miles, it's a kilometre is 5/8 of a mile. If you don't know 5/8, it's 0.625. And in fact, I was out in it this afternoon, and a mixture of urban and suburban driving, and we were getting 6.4 miles per kilowatt hour. Now on Intelligent Octopus Go, I get 7p per kilowatt hour cost. So if you want that in euros, multiply by 1.16, I think. If you want that in dollars, multiply by 1.33 at the moment. Since President Trump has been doing his stuff with the tariffs, the pound's gone up against the dollar, so 1.33. 7p per kilowatt hour to charge. No, 6.4 miles per kilowatt hour, sorry. So that's nearly just over 1 pence per mile to drive this thing in fuel costs. But would you believe it, when you go to charge points, you get sales. So you'll get a flag. I use the Electroverse app, and you get a flash on the Electroverse app saying, oh, such and such has got a sale, 10% off and so on. But actually, one night this week, Octopus, my home supplier, had a 50% sale. So that's half price. So it's 3.5 pence per kilowatt hour to charge the car. So at 6.4 pence, no, 6.4 miles per kilowatt hour, sorry. Well, you're around about, you're in the sort of zone of half a pence a mile. Half a pence a mile. And I looked at the cost of petrol, gas. If you got 50 miles per gallon, that would be 13 pence per mile in fuel. So you're around about 20 to 25 times cheaper to drive one of these. At least the e-up anyway. You've still got to buy it in the first place, and they still are more expensive, but they're coming down. So I think that'll do. I think that's been long enough, hasn't it? Yeah, just practical stuff for technical people perhaps who have got one of these EV charge points. I say charge point because of course the charger is in the car. What's coming out of here is AC. This is conditioning it. This has got some safety trips in and stuff like that. Integrates with the app so I can put timers on it, but what comes out of here is AC. It's only DC going into the car if you go to one of the fast chargers. Thanks for watching.